evening all of you. Today we are going to see an important topic about doing practicals. Practicals in the sense lab practicals and troubleshooting only with voltmeter. So most of the time in the lab, if you check it out, the ammeter won't work, especially this micro ammeter and all. Because of wrong connection, usually the ammeter is likely to fail. And getting the ammeter from the lab is very difficult. Very difficult in the sense, almost all the ammeters in the lab will be in failure condition. So to avoid that, we can do the same experiments or we can troubleshoot the circuit just using the voltmeter. So for this we will go by we are familiar with nodal analysis in circuit theory. Just we are going to adopt the same concept and then we can find out all the parameters. Okay. For example, suppose I want to study or practically verify the forward characteristics of a diode. So this is the circuit diagram. Generally what we will do, we will connect an ammeter to see the current and an voltmeter across the diodes to see the voltage across the diode. Instead of that, what you can do is take this as reference, say 0 volts. Assume this value we must know, say 1 kilo ohm. How do we know this? That is 1 kilo ohm. Before conducting the experiment, with the help of color coding, you can find out the value. Second thing, with the digital multimeter, you have the facility of finding out the resistance of the resistor. That means, for doing this experiment, before connecting all the components, check whether all these components are working properly, and especially for resistance, you must know the value. Then only this method is easy. Okay. Now what you do is, you have an analog or digital multimeter. In that you choose the voltage range. For example, say this is variable and can go up to 0 to say 5 volts. So what you do is, you have a voltmeter, positive, negative, okay, and you can choose, since I will be going up to 5 volts, what you can do is, you can choose the range from 0 to 10 volts. What you do is, suppose initially this was set to say 0.1 volt, then this range is very big, so for that case you can choose 0 to 1 volts. You have that provision in digital multimeter while using in voltmeter mode. So what you do is, this end you connect this. So with respect to ground, whatever potential you see here, I call this as V in and this potential as V out. So in the tabulation, what we will know, V in, V out. So when you connect here, we know the voltage. For example, if it is going to read out 0.1 means, here you can register 0.1 volt. Now what you do is, the same voltmeter, just you connect this end here. Now it is going to read out V out. V out means with respect to ground or 0, you are measuring this voltage. So now V out will be 0 because suppose if it is silicon diode, to make the silicon diode conduct, you need roughly 0.7 volts to conduct. Now it is only 0.1, so definitely silicon diode will not conduct, current will be 0. So the voltage drop across R is 0. Those things we know. So now this is going to read 0 volts. Now this is current, forward current. So IF Now what is IF? IF is nothing but V out. This end is V out, this end is 0. So V out minus 0. So that means V out minus 0 is the voltage drop across this R divided by R. So this is another column. Okay. So now you can use it. Now you know V out is 0, 0 minus 0 by R. Now how to find VF? So forward voltage. That is also you can include in the same tabulation. VF is what? This is the forward voltage, which is nothing but V in minus V out. Okay. So since I don't have space here, I am writing here. So V in minus V out, that is 0.1 minus 0. So this is going to give you forward voltage as 0.1. Suppose if you keep on increasing, you can record all the readings. At one point, say 0.7, V in is, I am setting this to 0.7 volts. So just the diode will be on. So with respect to ground, this will be 0.7. Okay. Just the diode is on. So the voltage drop here is 0. So V out here will be 0, or you can see some negligible voltage. So roughly approximately equal to 0 volts. So IF is V0 minus 0. V0 is what? 0 minus R is 0. So here also you will be getting 0 milliamps. But when you go for 1 volt, say 1 volt, what you do? When you touch here, V in is going to read 1 volt. When you touch here, you will be getting some voltage. But we all know that V in minus V out will give you 0.6 or 0.7. Okay. So this will take 0.7. So here it will read 0.3. So when you touch here, roughly it will read 0.3. Okay. Now what is the current flowing in the circuit? The voltage drop across the resistor is V0 minus 0. That is 0.3 minus 0 divided by 1K. This is going to give you 0.3 milliamps. Now coming to forward voltage, what it will give? V in we know 1 volt. V out is 0.3. So that will give you 1 minus 0.3. This will give you 0.7 volt. Now suppose if you give 2 volts, of course you have to adjust this range, make it as 0 to 10. So suppose if this voltage is 2 volts, this is going to take away 0.7 volts. So this will experience 1.3 volt. That means with respect to ground, V out will be 1.3 volts. And this end you will be having 2 volts. So now V in is 2, V out is 1.3. So V in minus V out, it is going to have the same value, which is V 0.7. Or there may be some negligible increase in voltage. So 2 minus, now we have to find a forward current. 1.3 minus 0 is 1.3. 1.3 divided by 1K, which is going to give you 1.3 milliamps. Okay. Likewise, you can increase the voltage up to 5 volts or 7 volts or up to 12 volts. Choose the correct value of resistor. So by this method, without using ammeter, we can do the experiment. Okay, just by using a single voltmeter. So what you have to do, first connect here, then you connect here, record these values. So you can change the voltage, input voltage. Since this is a variable source, you change, correspondingly you plot, you will be getting the forward voltage and forward current. So what is the requirement here? The requirement here is you must know the value of R. R here is 1K. How I got this 1K? The 1K you can read out from color coding, but that will have a tolerance value. So the best method is, after reading out the color coded value, once again you check with a standard meter, say fluke meter, not an ordinary digital multimeter. You can buy fluke meter. In that you set the ohm, you choose the ohms range and measure the resistance. So when you measure the resistance, see that your hands are not touching the component. Okay, so both the ends, because if you touch means what will happen means your body resistance between these 2 points will come in parallel with that resistance, so it is likely to modify the resistance value. So touch the insulated parts of the wire and then touch the component and measure the value. That will give you fairly accurate value. So that value you can write down here. Suppose this is I have written just by looking at the color coded value. But when you measure with Fluke company, a standard very good digital multimeter, it may read out say 0.9K, 0.93K or 1.1K or 1 point something. It need not be accurately 1K. So the only one condition what you have to remember is you must know the value of the resistance. How to find the value of the resistance? By color coding, or you can use a good quality digital multimeter. In that you can choose voltage range, ohms range, and then you can find the value of the resistance. So you need not worry whether a multimeter is available, a good multimeter, a good ammeter is available in the lab or not. Absolutely not at all required. With single voltmeter you can do the experiment without any problem and you can record the values. In fact, this will give you more accurate results than using the ammeter, because ammeter will be having some internal resistance that also will comes into picture. Those things also we have to take into account while doing the experiment. Hope you have understood the method of using voltmeter for doing the lab experiments. Same concept is applied for troubleshooting any kind of say television set or any kind of electronic system or equipment. Just by using voltmeter, a good quality voltmeter, we can always find out, we can troubleshoot what happened with a particular component or not. Hope you have understood this video of how to use a voltmeter for lab purpose. Thanks for watching this video. Nandri.